Okay, today we're going to be talking about elimination. So remember, there are 3 ways that we're learning this year on how to solve a system of equations. The first would be graphing. So we would take our coordinate plane, graph both lines, and see where they intersect. The second would be substitution, where we take one equation and we plug it into, we take this and plug it into the other equation and solve it out. Today we're talking about elimination. So when we're doing elimination, we want our equations in standard form, which is ax plus by equals c, or something x plus something y equals number. We will multiply for opposites, add the equations together, solve for the first variable, plug that back into one equation, and solve for the other variable. So first, what's an opposite? 3 and -3 are opposites, so they're both the same distance from 0. So if I were to add them together, I would get 0, meaning they would cancel out, or keyword eliminate. So I have these 2 equations. They're in standard form. Something x, something y equals number. That is key for these. If I look at these first and I want to eliminate the y's, so here are our y terms. We want to eliminate those. We need them to be opposites. So I always think to myself, is there a way that I could make this -3 into the opposite of the bigger number? So 6, opposite of 6 would be -6. Is there a way to make the -3 into a -6 through multiplication? Yes. I can multiply by 2. However, if I multiply by 2, I have to multiply the entire equation by 2. So let's see what that looks like. 2 times 2x is 4x. 2 times -3y is -6y. 2 times 5 is 10. Do not forget to distribute to the other side of the equal sign. The second equation I leave as is. 4x plus 6y equals 7. My next step would be to add the 2 equations together. 4x plus 4x is 8x. -6y plus -6y is 0y. They cancel out. Equals 10 plus 7 is 17. Look how I got my x alone now. One more step to get x alone would be to divide by 8. This is just going to be a little introduction. Maybe I'm giving you the first 2 baby steps before we do a whole problem. This time I'm asking you to eliminate the x's. So here's our x's. Focusing in on those. So I'm thinking, can I make this 2 become the opposite of 4? So in other words, can the 2 become a -4 through multiplication? Yes. I would have to multiply by -2. When I distribute that to every term, this top equation becomes -4x. -2 times -3y is plus 6y. -2 times 5 is -10. We're not manipulating the second equation, so bring it on over. Now to add the 2 equations. -4x plus 4x is 0, so they'll cancel. 6y plus 6y is 12y. -10 plus 7 is -3. Then I would divide by 12 to find out what y is. All right, one more, practicing just the first 2 steps. So this time it says, if I want to eliminate the y's, what should I do? So here's my y's. All right. The top one is a -2y and the bottom is a 5y. Is there an easy way to make the -2 into the opposite of 5? Well, through multiplication. There isn't without multiplying by a decimal or a fraction. So let's think of their least common multiple. What number can I make -2 and 5 become that's larger through multiplication? they both go into 10. All right, so next thought is one has to be negative 10, one has to be positive 10. So how do I get this negative 2 into a negative 10? I multiply by 5. How do I get this 5 into a positive 10? Multiply by 2. Distribute it out. 5 times negative 2x. Try to pause your video and distribute this on your own. 5 times negative 2x is negative 10x. 5 times negative 2y is negative 10y. 5 times 8, 40. Second equation, we had to multiply there too. 2 times 4x is 8x. 2 times 5y is 10y. 2 times 9 is 18. Next step would be to add them together. Negative 10x plus 8x is 2x. Negative 10y plus 10y is 0y. And 40 plus 18 is 58. Then I would divide by 2, and I would know what x is. Next question. What did Mrs. Algebra do wrong? So look at these. She wanted to eliminate the x's. What did she do wrong? So she was trying to get those x's to go away. She distributed this, and it became negative 10x. Then when she distributed this, it became negative 10x. Well, when I add those together, they don't cancel out. So she did not create opposites. In order to do that, she probably would just have to distribute a positive 5, and then it would work. All right, let's do our first problem all the way through. I'm giving you a graph that will help you kind of visualize our solution. So our solution is still going to be where those two lines cross, and here's a new method, elimination. So step 1, get opposites. So let's hone in on just the x's. Is there a way that the 2 can become the bigger number? Can the 2 become a 3 easily? No. Okay, so next thing I want to focus in on are the y's. Is there a way that this negative 3 can become the opposite of 6? So negative 6 easily. Sure. I can multiply the bottom equation by positive 2. I'm not changing the top equation at all, so you could think about it as multiplying by a 1. But that's not absolutely necessary. So I'm going to go ahead and rewrite the top equation. 3x plus 6y equals 30. And the second equation, multiply 2. 2 times 2x is 4x. 2 times negative 3y, negative 6y. 2 times negative 15, negative 30. Now we add the two equations. 3x plus 4x is 7x. 6y plus negative 6y is 0. 3 plus negative 30 is plus 27. And let's take a look. Here's what went wrong. I wrote this down as a 3 instead of a 30, which will change this side of my equal sign. Now we have 30 plus negative 30, which is 0. Hopefully you caught that. Divide both sides by 7. X equals 0 divided by 7 is 0. Now, some people are like, wait a second. When I did this step that I'm highlighting here, isn't that no solution since they're not true? But that no solution only comes into play if my x's completely go away. So I would have like 7 equals 0. Then it would be no solution. Looking at my steps, multiply to get opposites, check, we did that. This was step 1. Step 2, add the equations together, did that. Step 3, solve for the variable, did that. Step 4, plug back into an equation and solve. So let's plug it back into our top equation. 3x plus 6y equals 30. I know that x is 0, so it's going to go in here. 3 times 0 plus 6y equals 30. 3 times 0 is 0, so 6y equals 30. Divide by 6, so y is 5. Last step is to write my ordered pair. It should be x, y. So 0, 5. All right, next equation. We have 5x minus 2y equals negative 11. Negative 3x plus 7y equals negative 5. So let's focus in on just the x's first. Is there a way that this negative 3 can become a 5 easily? Nope. Not with one move. And the y's. Is there a way that this negative 2y can become a 7y? No. So I have a choice. I can either eliminate the x's, in which case I would have to multiply both equations by something, or I can eliminate the y's. In the same case, I would have to multiply both equations by something. If you eliminate the x's, we can make the x's into 15 and negative 15. For the y's, we could make it negative 14 and positive 14. So let's go ahead and eliminate the x's. To make this 5 into a 15, I'll multiply by 3. To make this 3 into a 15, I'll multiply by 5. And we want it to be negative 15. So let's do that. 3 times 5x is 15x. 3 times negative 2y is negative 6y. 3 times negative 11 is negative 33. 5 times 3x is negative 15x. 5 times 7y is positive 35y. And 5 times negative 5 is negative 25. Step 2, add them together now. 15x plus negative 15x is 0. Negative 6y plus 35y, 29y. Negative 33 plus negative 25, negative 58. Next step to get y alone, let's take 58 and divide negative 58 divided by 29. So y equals negative 2. Last step, plug that back into an equation. Now we have a choice. We can plug it into the first, the second, or the new first, or the new second. It does not matter. When I plug in, let's go ahead and throw it into the first equation. So it's 5x minus 2y. Well, I know that y is negative 2. Equals negative 11. So our y's went away. This was y here. And I plugged in negative 2. So 5x, negative 2 times negative 2 is a positive 4. Subtract 4 on both sides. 5x equals negative 15. Divide by 5 on both sides. So x equals negative 3. Final solution, negative 3 common negative 2. Next question. Pause the video. Think about what variable you want to eliminate. Okay, if you want to eliminate the x's, we could make these into 12. We could make them into 24. We could make them into 36. We've got some options. So if I make them into 12, the 6 to become a 12, I would multiply by 2. The 4 to become a 12, I would have to multiply by 3. Okay, but one of them has to be negative. Does not matter which one. I'll make the top equation negative. So let's distribute. Negative 2 times 6x is negative 12x. Negative 2 times negative 8y is plus 16y. Negative 2 times negative 6 is plus 12. And second equation, distribute. 3 times 4x is 12x. 3 times negative 10y is negative 30y. 3 times 10 is 30. Add it up. Negative 12 plus 12 is 0, so those x's cancel. 16 plus negative 30y is negative 14y. 12 plus 30 is 42. Last step to get y alone, I divide by the number in front of y. Divide by negative 14, so y equals 3. Okay, I've got y. Now I need to find out what x is. So let's take it and plug it into our first equation, and we will plug it in for y. Highlighted the wrong thing. So 6x minus 8 times, this is y, but we know that y is 3. So 6x, 8 times 3 is 24, negative 24. Add 24 to both sides. So 6x equals 18. Divide by 6. X is 3. So we've got 3, 3. Okay, next question. All right, I like these ones. When I have one of them that has just an X or like a 1 in front of it, I know that I can easily make that into the other number. So I can make a 1 into a 2 really easily. I would multiply the top equation by 2. One has to be positive, one has to be negative, so we'll go ahead and multiply by negative 2. Distribute that. I've got negative 2x minus 6y equals negative 10. Don't forget, distribute it to every term. I'll drop down my second equation, 2x plus 6y equals 2. Add them together. Negative 2x plus 2x is 0. Negative 6y plus 6y, that's also 0. Okay, I've canceled out everything on the left, so I have 0 things on the left, so I put a 0 there. Negative 10 plus 2 is negative 8. Well, that's not a true statement. 0 does not equal negative 8. So what's our answer? No solution. Okay, or 0 with a line through it. Why is it no solution? Think about what does it look like on a graph? These lines are parallel on the graph. And they would not cross each other. Let's try another. Okay, we have a negative 6 and a positive 6 and a negative 3. So we could get rid of the x's by changing that negative 3 into a negative 6, multiplying by 2. Or let's see the y's. The y's here, we have a 10 and a negative 5. So we could change this negative 5 into a negative 10 by multiplying by 2. So let's take the second equation, multiply by 2. Top equation will remain as is. 6x plus 10y equals 0. Bottom equation, 2 times negative 3x is negative 6x. 2 times negative 5y is negative 10y. And 2 times 0 is 0. Add them up. 6x plus negative 6x is 0. Cancel. 10y plus negative 10y is 0. Cancel. So 0 equals 0 plus 0 is 0. Well, that's a true statement. So what's my answer? Infinitely many solutions. What does this look like on a graph? Well, if I were to graph these, they would be the exact same line. So write yourself a note, same line. Okay. Now, this first question is pulled from your day 4 homework. We did it once using substitution, and we got fractions. Let's take a look and see what it looks like if we do elimination. We don't have to deal with fractions. Some might say this is easier. So, my goal to be able to use elimination is to first make sure that I have like terms stacked on top of each other. I do not. I need to work to get this negative 2x over to the left side. How do I do that? Well, if I move the whole term, it's negative, so I will go ahead and add 2x to both sides. So when I rewrite my first equation, I have 2x, a positive 7y, so 2x plus 7y equals 1, and these 2x's cancel. Then I'll rewrite my second equation, 3x plus 5y equals 7. Now notice, I have my x's stacked on top of each other, I've got my y's stacked on top of each other, and I have whole numbers. That's how we want our questions set up in order to be able to use elimination. So that was the first step. You must first manipulate the problem so x and y terms are aligned. So step 1, multiply to get opposites. So I have a 2 and 3 and a 7 and a 5. Let's tackle the 2 and 3. If I want to make them both 6, I would multiply the top equation by 3, the bottom equation by 2. One of them has to become a negative 6 to be opposites. So we'll do that on the top equation. Negative 3 times 2x becomes negative 6x. Negative 3 times 7y, negative 21y. Negative 3 times 1, negative 3. 2 times 3x is 6x. 2 times 5y is 10y. 2 times 7 is 14. Add them up. Negative 6x plus 6x, 0. They cancel. Negative 21 plus 10 is negative 11y. Negative 3 plus 14 is 11. Divide by negative 11. So y equals negative 1. Let's take that negative 1 and let's plug it in to this equation. So 3x plus 5y. Well, we know y is negative 1. Equals 7. 3x. 5 times negative 1 is negative 5. Equals 7. Plus 5 on both sides. 3x equals 12. Divide by 3. So x equals 4. Final answer should be in ordered pair since we're getting numbers here. 4, comma, negative 1. So compare that to the work that you had to do for the substitution version of this question. In my opinion, this way is a little bit easier, but that is my opinion. If you get to one like this on your test and it says use any method, then you get to choose elimination or substitution. Let's do another one like it. Again, this is pulled, same question from your day 4 homework. Let's go ahead and add 4x so we can align those in our equation. So I have a 4x plus a 3y equals an 8, and these cancel. Drop down or pull aside your second equation. Now, let's see what we can cancel. We could cancel our x's. What would we have to do? Can we make this 4 into a opposite of 8? So can we make the 4 into a negative 8? Sure, we multiply by negative 2. So negative 2 times 4x is negative 8x. Negative 2 times 3y is negative 6y. Negative 2 times 8, negative 16. Second equation. We're not changing it. Keep it 8x plus 6y equals 12. Add them up. Negative 8x plus 8x is 0. Negative 6y plus 6y is 0. So canceled those out on the left. Negative 16 plus 12 is negative 4. That is not a true statement. 0 does not equal negative 4. So what's our answer? No solution. Next one. We got 2 more here. Last one like this, I want them to stack up. So let's move the 3y to this left side. So first I'll write down the x term, then the y. So 2x, and then the 3y. So plus 3y equals, these cancel, positive 7. Bring over 4x minus 2y equals 6. All right. Well, the y's are already opposite signs, so that's a point in their favor. And the x's, well, a 2 can become a 4 pretty easily. So if I am changing the x's and canceling those out, I would multiply the top equation by negative 2. If I wanted to eliminate the y's, I would multiply the top equation by 2 and the bottom by 3. Multiply this through. Negative 2 times 2x is negative 4x. Negative 2 times 3y is negative 6y. Negative 2 times 7 is negative 14. Keep the second equation as is. We didn't need to manipulate it. Add them together. It's always addition here. Negative 4x plus 4x is 0. Negative 6y plus negative 2y is negative 8y. Be cautious with your positive and negative numbers. Negative 14 plus 6 is negative 8. Divide by negative 8, so y equals 1. Now let's take that 1 and let's plug it into the second equation here. 4x minus 2y, which is 1, equals 6. So 4x, negative 2 times 1 is negative 2. Add 2 to both sides. Divide by 4. X equals 2. Getting these numbers, so my final answer should be an ordered pair. X, y, so 2, 1. And the last question. Elimination. My y's are stacked, or my x's are stacked, my y's are stacked, and I've got whole numbers. So we are in good company here to start elimination. Create opposites if necessary. Well, these x's are not opposites. They're 1x and 1x. The y's are negative 1x, negative 1y, and positive 1y. Those are opposites. If I add them right now as is, 1x plus 1x is 2x. Negative 1y plus positive 1y, 0 y's. 4 plus 4 is 8. Divide by 2, x equals 4. Plug it back into one of the equations. 4 would go in here. So 4 plus y equals 4. Subtract 4, y equals 0. 4, 0 is my solution.